We have been fascinated by the idea that other planets, like Earth, might support life for as long as humans have been observing these skies. Our trips to the moon have shown us that it is entirely lifeless and uninhabitable, but other planets in our solar system still have lots of promise. Venus cloud tops could support life. Life may exist on Neptune and Saturn in a subsurface ocean of liquid water. Even Titan's liquid hydrocarbon lakes offer an intriguing environment to look for unusual life things. The most intriguing possibility, though, is Mars, which is a red planet. The surface of this smaller, colder, farther off cousin of Earth very definitely once contained flowing liquid water for more than 1 billion years. The existence of life on Mars, not just in the distant past, but maybe even now, and possibly intermittently, has been suggested by circumstantial evidence. In this video, we're going to talk about scenarios that could explain how life exists on Mars. So, let's get started. Scientists have discovered tons of exciting discoveries on Mars using the data from numerous orbiters, landers, and rovers. On Mars' surface, we see dried up riverbeds and signs of previous glacial periods. Both sedimentary rock and the small hematite spheres that are discovered on Mars are products of watery ecosystems that only exist on Earth. Additionally, it was discovered Mars has snowfall, frozen surface water, and solid subsurface ice in real time. Even if that finding is still debatable, we have heard salty surface water is actively streaming down the edges of numerous craters. Early Mars also had an abundance of basic materials needed for life, such as a dense atmosphere and liquid water on the surface. There are 3 pieces of evidence indicating past or perhaps contemporary life may be a possibility, even though Mars no longer seems to be teeming with life today. The equipment on board NASA's Mars Viking landers provided the first strong piece of evidence in 1976. 3 biology experiments were conducted: a label release experiment, a pyrolytic release experiment, and a gas chromatograph mass spectrometer experiment. Only the first time the labeled release experiment was run on both Viking landers did it provide a successful outcome. The results of all the other experiments were negative. The discovery of Allen Hill's 84001, a chunk of Mars meteorite on December 27, 1984, provided the second piece of proof. Roughly 3% of all meteorites that hit Earth are from Mars, but this one was especially big and weighed close to 2 kilograms. It was created on Mars about 4 billion years ago, and it only arrived on Earth about 13,000 years ago. When there was an investigation inside of it in 1996, it was found what might be the remains of extinct biological life forms, albeit they could also have been developed through inorganic processes. The third piece of evidence was revealed by NASA's most recent Mars rover, Curiosity. Curiosity observed methane burps from particular subsurface places as Mars seasons changed, but only towards the conclusion of the Martian winter and the start of spring. Again, this is a signal that is at best equivocal because both organic and inorganic biological processes, as well as seasonal geochemical processes, have the potential to produce methane. There are 5 possible scenarios for the emergence of life on Mars when we consider all available data and all that we know about the planet. It could have current life in it today. It could have been seeded by Earth life at some point in the past. Or it could only contain Earth-based organisms that have migrated there since the advent of the space era. It could also be an internally lifeless world. Moving forward to the video, we will discuss what each scenario would entail. If you are enjoying the video, please do not forget to subscribe to our channel. Let's continue. Number 1. Mars has never supported life. Despite having these same materials as early Earth and comparable wet climates, the condition required for life to emerge just never materialized on Mars. Nothing biological occurred, yet all the inorganic geological and chemical processes did. Then, a little more than 3 billion years ago, the Sun stripped Mars' atmosphere away, drying out any liquid surface water and causing Mars to take on its present form. This is the most cautious position and calls for either inorganic or contamination-based resolution for each of the 3 allegedly evidenced tests. This is very likely and continues to be the common presumption in many people's minds. This will probably continue to be the dominant theory until some extremely strong evidence that firmly points to either past or present life on Mars appears. Number 2. Early life on Mars existed but was extinguished. In many ways, this situation is just as intriguing as the previous one. It's fairly simple to picture a world, and that includes a day that is equivalent in length to our own. A thick atmosphere, akin to that of early Earth, stable liquid water on the surface, volcanoes, a magnetic field, temperatures only slightly colder than those of today's Earth might result in life. Given that life only emerged on Earth a few 100 million years after its formation, it seems almost unfathomable to many that these circumstances, after more than 1 billion years, wouldn't lead to life. The loss of the Martian atmosphere, however, had a significant impact on the planet, and might have led to the extinction of all life there. The proof for this hypothesis might be found by drilling into the sedimentary rock on Mars, and looking for petrified organisms or even metamorphosized carbon-rich inclusions. Number 3. Life first arose on Mars and is currently present beneath the surface, largely dormant. The most idealistic theory of life on Mars is still supported by science. It's possible that life evolved on Mars early on, and that a small number of extremophiles survived the loss of the planet's atmosphere in a frozen, suspended animation form. That life wakes up and starts carrying out its essential biological tasks when the correct circumstances arise, probably underground where liquid water can occasionally flow. If so, it means that there still may be life on Mars, potentially in the shallow dunes just a few feet or even a few inches below our spacecraft. Even though we are most likely only discussing a single-cell life, and may not even be approaching the complexity eukaryotic cells, the discovery of life on any planet other than Earth would represent a scientific revolution. Critical soil samples will be collected by NASA's Perseverance rover, which was successfully launched on July 30th, 2020, to investigate this speculative scenario. Number 4. Life on Mars was not present before Earth seeded it. The fifth great mass extinction in Earth's history occurred 65 million years ago, when a very huge, rapidly moving object collided with Earth, leaving the Chicxulub crater and churning up enough debris to cover the planet in a cloud of debris. And, like many large impacts, this one may have scattered small fragments of Earth into space, much like impactors on the Moon or Mars shoot meteors into space, some of which may have ended up on Earth. A few impacts may, however, have the opposite effect, delivering debris from Earth to other planets like Mars. It doesn't make sense that the organically rich stuff in Earth's crust wouldn't travel to Mars at all. Instead, it seems incredibly likely that organisms from Earth traveled to Mars and started to reproduce there, whether they survived or not. Maybe one day we'll be able to fully understand the history of life on Mars, and whether any of it shares the common ancestor as all living things on the planet today. It's an intriguing idea that's difficult to rule out. Number 5. Earth-based life was brought to Mars via our current space program. And finally, it's possible that Mars genuinely was a dead, arid planet up until the advent of the space era, at least for billions of years. It's possible that objects from space that weren't completely sterilized or decontaminated ended up on the surface of Mars and carried modern Earth species as stowaways. Scientists' worst nightmare is that, although there may be a fascinating history of life on another planet still to be discovered, we will pollute it with our own species before we ever learn the true story of life there. There is a great deal of hope that current and future generations of Mars rovers and orbiters will assist us in determining if Mars has ever supported life, either currently or in the past. If the answer to this question is yes, it raises a crucial follow-up inquiry. Is that life connected to or separate from life on Earth? It's plausible that life began on Earth and spread to Mars, that life began on Mars and then spread to Earth, or even that life existed before Earth and Mars and that its earliest forms spread to both planets. But, as of right now, scientists don't have any convincing proof that life has ever lived on Mars. There are a few signs that could point to past or present life there, but all of those results could be explained by completely inorganic processes. As always, the only way to get the truth is by carrying out more and better scientific research, using better tools and methods. The next step will be to send the soil samples back to Earth for laboratory study, while NASA's Perseverance rover continues to collect a variety of soil samples. If we are successful, we may be able to determine which of these 5 scenarios best fits the reality of Mars within the next 10 years. Do you think life exists on Mars? If you're interested in knowing about space discoveries, take a look at our video on Voyager 1 that is shown here. If you have any topics that you would like us to cover, let us know in the comment section below. We hope you enjoyed today's video, and if you did like it, please don't forget to subscribe to the channel and press that bell icon, and we'll see you in a new video. Take care.